Good morning, everyone. Today we are going to solve Physics 5054 MCQ paper Winter 2019 1-2. Winter 2019 1-2. On your screen, you can see the first question. Which word is the same as a vector quantity? Density, display. Which word is the name of a vector quantity? Sorry. Density, displacement, energy, speed. Density, energy, and speed, they all are scalar. Displacement is a vector quantity. So the question number one, the option will be B. Question number two on your screen. What is the size of the resultant of the two forces shown in the diagram? Okay, here he has shown two forces, 3 Newton force in the upward direction, 4 Newton force in the horizontal direction. The angle between the two forces is 90 degree. If you will complete the parallelogram, it will be in the shape of a rectangle. And if I will join the point where the tails are joined with the opposite corner of the rectangle, or the this will be the resultant. And to because it's a rectangle shaped parallelogram, so this side will be 4, this side will be 3, and I want to find this diagonal. And you can apply the Pythagoras. 3 square plus 4 square equals to 25. We take its under root to get the value of the hypotenuse. That will give me 5. 3 square plus 4 square, it will be 25. Take its under root, it will be 5. So it's a famous right angle triangle, 3 4 5. So the answer is C choice, 5 Newton. Next question number 3 on your screen. What is the correct unit of for the quantity shown? Correct unit you have electromotive force, Newton. Electromotive force is not a force actually, it is voltage. Latent heat, the latent heat is measured in joules. Yes, that's true. Pressure is in kilojoule kg per meter cube. That's wrong. Weight in kg. That's wrong. So the unit which is correct is the latent heat, and it's latent heat is basically amount of heat. So its unit is joules, J. So the option is B. Question number 3, the option is B. Question number, let's move to the next question. Question number 4. He says, length of the copper pipe of uniform cross section and several meters long carries water to a tap. Measurements are taken to determine accurately the volume of the copper in the pipe. Which instruments are used to for finding the volume of this pipe? I need to know the length of the pipe, and I need to know the internal diameter of the pipe. For the internal diameter of the pipe, we use vernier caliper, and because it's several meters long, so I will use the tape. So I need to use the tape and the vernier caliper. So the option is D. The best option for question number 4 will be D. Okay, the question number 5. On your screen, you can see question number 5 right now. Part of a speed time graph for two runners is shown. They are running along the same track. It's a speed time graph. Which statement must be correct? Both runners started at the same moment. Runner 1 has a greater acceleration than runner 2. Runner 1 is moving faster than runner 2. That's true. The distance between the two runners stays constant. I think the very easy and obvious thing from here, you can see the runner 1 has a constant speed and it's larger. Runner 2 has a constant speed, but that speed is smaller as compared to runner 1. So runner 1 is moving faster than runner 2. The C is the best option. Let's move to the next question, G. Question number 6, and yeah, this is now on your screen. Question number 6. The graph shows how the speed of a car varies with time. It's a speed time graph shown. Which statement about the acceleration of the car between the time 10 second and 20 second? If you look at the graph, speed time graph at 10 second and 20 second, during this, the graph is flat. The speed time graph is flat. It means its gradient or its slope is 0. The gradient of the speed time graph represents the acceleration. If the gradient is 0, the slope is 0, the acceleration will be 0. So the best option looks D. The acceleration is 0. Question number 6. The option is D. If we move to the next question, question number 7 on your screen right now, uh, in which descent is the acceleration equal to the acceleration of the free fall g at all times? A bungee jumper leaping from a bridge, a feather falling in a vertical tube with which that contains a vacuum, a hailstone traveling to Earth at terminal velocity, a skydiver dropping from an aircraft to Earth. The Whenever an object starts falling on Earth, its acceleration is equals to 10 meter per second square. But when he faces the air resistance, the amount of acceleration reduces. But if you have vacuum, then throughout its fall, its acceleration will remain constant. So B is the choice, a feather falling in a vertical tube that contains a vacuum. So question number 7, B is the choice. Question number 8 on your screen right now. A body slides down a frictionless slope as shown. As the body presses on the surface pushes back on the body. In which direction does the surface pushes back on the body? He's talking about the normal reaction of the surface. So when you place the object on an inclined ramp, the normal reaction will be perpendicular to the surface. So the best choice is C. C is the normal reaction of the surface. Question number 8. Uh, the choice is C. Let's move to the next question. Question number 9. Let me reduce its size a little bit. Yes, now it's visible to everybody. The whole question is visible. Question number 9G. The Earth travels at a constant speed in a circular orbit around the Sun. Which arrow shows the direction of the acceleration of the Earth and the direction of the velocity of the Earth? Remember, when you are moving in a circle, the direction of the acceleration is always towards the center of the circle, and the direction of the velocity is always tangent to that circle. So if you look at here, the direction of the acceleration will be towards the center. That direction is shown here with R, and the direction of the velocity will be tangent to that circle at that point where that object is right now, and that is represented here with Q. So the acceleration or the direction of the acceleration will be R, and the direction of the velocity will be Q. The D is the option. Question number 9, D is the option. Let's move to question number 10. Right now on your screen, you can see question number 10. It says a student balances a non-uniform object on a pivot. To do this, a weight is suspended near the left-hand end of the object as shown. Where is the center of the object? You see, center of the mass of the object will be here somewhere, but he has balanced that object on this pivot, but he has done an extra thing. He has hung a weight here. So not just the whole weight of the object is acting here, an extra weight is hung on point A, sorry, and because it is acting here, so it's trying to produce a anti-clockwise movement about the pivot. So nothing other than the weight of the object is there. There's no other force. So to balance this anti-clockwise moment, the center of the mass should be on the point D. Here, the center of the mass should be. So the weight of this object will produce a clockwise moment and will balance this anti-clockwise moment. So my idea is that the center of the mass should be on the point D. Question number 11. Okay, we have to reduce its size a little bit. No. Let me adjust it. Yeah. Okay, so you can see on your screen question number 11, a load L is suspended from two springs that are in parallel. The extension of each spring is X. The springs are then arranged to hang vertically one below the other. In this new arrangement, what is the total extension of the two springs? You know, when you have this first situation, these two springs are parallel. You uh, hung a load L, and because these two springs were parallel to each other, so this load was um, distributed on them, and X extension was produced. But when you change the situation, now you are hanging the springs in this way. Now when you hung the load L, this whole load is acting on this spring, and it is also acting on this spring. Here this spring was experiencing only L by 2 load, but here it is experiencing the full L load. So here the extension X was producing this, but here because the load has doubled, which is experienced by this spring, so that's why before this spring has an extension of X, but this time the extension in this spring will be 2X. And the same here, this experience before has, this spring before has an extension of X, but in this situation the full load is acting on it, so it will have extension of 2X. So 2X extension in this spring, 2X extension in this spring, so the total extension will be 4X. So the choice is D. For 11th question, the choice is D. Okay, now move to the next question. We have question number 12. And the question number 12 is, let me adjust it. Okay. Question number 12. The diagram shows 3 tubes P, Q, and R. Each tube contains air trapped by a water column. Which statement? The pressure of the trapped air is equal in tube P, Q, and R. The pressure of the trapped air is the greatest in the tube Q. The pressure of the trapped air is the greatest in the tube R. The pressure of the trapped air is greatest in tube P. You see, this air is trying to push this water outside of this tube. In all of them, the air which is trapped here is trying to push the water out of this tube, and the atmosphere is trying to stop that. So a balance has created, and we can see that the level of the water in all the tubes is same. The vertical height of the water from the level of the water from this tray is, the vertical height is same. So it means the pressure of this air is same. So the pressure of the trapped air is equal in the tube P, Q, and R. Question number 12A is the option. I hope you have understood. It's a little tricky question. Question number 13 is on your screen right now. Which graph shows the relationship between the pressure and the volume of a fixed mass of gas at constant temperature? The temperature is constant. What is the relationship between pressure, and if you increase the volume, the pressure will decrease? So if the temperature is, he's talking about gas. If the relationship between the volume of the gas and the pressure of the gas is inversely proportional, the graph of the inversely proportional is a decreasing curve. So C is the best option. C is the best option. This graph is a standard representation of two quantities who have the relationship of inversely proportion. Okay, on your screen, question number 14. An object X has mass m and velocity v. A second object Y has mass 2m and velocity 2v. What is the ratio of the kinetic energy of Y? You know the kinetic energy formula is half mv square. 1 by 2 multiply m multiply v square. If you double the mass, the kinetic energy will double, but when you double the velocity, the kinetic energy is increased by a factor of 4. So by doubling the mass, you made the kinetic energy double, and by doubling the velocity, the kinetic energy will become 4 times. The reason is half mv square. On velocity we have square, so the kinetic energy will become double due to the double mass, and the velocity will become 4 times larger due to the double velocity. So 2 into 4, 8. So the kinetic energy will be 8 times larger than the kinetic energy of X. So D, question number 14, D is the answer. Question number 15, where is the energy released by a fusion of hydrogen nuclei to form helium? It's called fusion reaction. This is happening on sun and it's happening on stars. So the answer is D, in the core of the sun. Question number 15, D is the answer. Question number 16, a student uses a Newton meter to pull an object a distance d horizontally along a flat surface in a time of t. The Newton meter reading is F. What is given by the expression F multiplied d divided by t? When you multiply the force and the distance traveled in the direction of force, this is called work. And when you divide the work with time, this is called power. So the option is C. Question number 16, the option is C. Question number 17 on your screen. A student is given a thermometer that reads 1 degree centigrade in pure melting ice and 101 degree centigrade in pure boiling water. He uses it to measure the temperature of some water before and after it is heated. How does the rise in temperature of the water calculated from him results compare with the correct values? Because when you will calculate the rise in the temperature, and that will be the final temperature minus the initial temperature. Although the final reading will be 1 degree larger and the initial reading is also 1 degree larger than the accurate or actual value, but when you take the difference will be the same, whether you use an accurate thermometer or whether you use this one which has a little bit zero error. The the readings will be 1 degree larger than the actual values, but when you take the difference will be the same. It is the same. Question number 17b is the option, sir. A student, question number 18 on your screen. A student makes 4 statements about evaporation and boiling. He says both involve an increase in molecular separation. Okay, both occur only at a fixed temperature. Both involve the absorption of thermal energy. Both occur throughout the liquid. Which 2 statements are correct? Both occur throughout the liquid. The 4th statement, that's totally wrong. So the A and B cannot be the choice. And both occur only at fixed temperatures. The second option is also wrong, because the evaporation do not occur at a fixed temperature. So wherever 4th and the 2nd statement is involved, they are not right. So the first is wrong, and the B is wrong, and the D is also wrong. The only right option will be C. Question number 18, C is the option. I mean the first and the third option, both involve an increase in the molecular separation. That's true. And both involve the absorption of thermal energy. That's true, sir. Achha, so the C is the option. You see here I use the technique. I just took out those who were, I know that they were wrong, and then I came to the right option. Question number 19, how is specific latent heat defined? Specific latent heat is the amount of heat required to change the unit mass of an object from one state to another state without changing temperature. Heat is denominated by having a change of state without a temperature. A is the right definition. So question number 19, A is the right option. Question number 20 is right now on your screen. A syringe containing air is sealed at one end. The piston is free to move. The air is heated. What happens? Piston is movable. Remember that thing, and you started hitting it. What happens to the average distance between the air molecules and the density of the air? Obviously, when you will start heating it, the piston will start moving to the right. The piston will start coming out of the syringe. So what will happen? The average distance between the air molecules, that should increase, and what will happen with the density of the air? That will decrease, because the volume of the air will start increasing. The mass obviously is not changing, so the density will decrease, and the average distance between the air molecules. So it looks that A is the choice. Question number 20, A is the choice. Question number 21. A metal disc is heated to 600 degrees centigrade and then lowered into a beaker of water. What happened to the mass of the metal disc and to the mass of the water in the, so see, this disc is heated to 600 degrees centigrade. The metal is hot, it's 600 degrees centigrade. So when you put it in the water, nothing will happen to the mass of the disc. The mass of the disc will have this, will remain the same. But when you put a 600 degrees centigrade hot metal piece into the water, the immediately some of the water will start boiling, and some of the water will convert into steam. So the mass of the water will start decreasing. It looks the C is the option. Question number 21, C is the right option, sir. Question number 22. It says which description defines the amplitude, sorry, which description defines the amplitude of a water wave in a ripple tank? It's the half of the vertical distance between a trough and a peak. That's true, G. The horizontal distance between the adjacent peaks, no. The horizontal, it's not horizontal distance. The vertical distance between trough and the peak, no. Not the from the trough to the peak, no. That's not the distance. The amplitude means from the mean position how high you went, or from the mean position how low you went. So if you talk about the top and the bottom, the trough and the trough and the peak, then whatever is that vertical distance divided into 2, you will get the amplitude. So A, 22A is the option. Next question, 23 on your screen. Here are 4 statements about wavefronts. Wavefronts from a point source are straight lines, yes, to some extent. Wavefronts from a point source from a point source, the wavefronts, for example, if you drop a stone in the water, that will be a point source. The waves which will produce in the water tank will be circular. So wavefronts from a point source are circular. Wavefronts are parallel to the direction of the energy movement. No, they are perpendicular. Wavefronts are perpendicular to the direction of the energy movement. So which statement is correct? If the waves are going this way, the waves are going this way, the wavefronts will be like this. They are perpendicular to the direction of the wave. So the second option is correct, that circular waves will produce, and the fourth option is correct, the wavefronts are perpendicular to the direction of the energy movement. So 1 and 4, 1 and 4 we have on the B. Question number 20. Wavefront, sorry, not 2 and the fourth are correct. Wavefronts from a point source are circular, and the wavefronts are perpendicular to the direction of the energy movement. Second and the fourth one are correct, so the D is the option. Question number 23, D is the option. Question number 24 on your screen. Yeah, an object. Okay, yeah, it's clear. It's not clear. Okay. An object O is placed in front of a plane mirror. I is the image formed. A ray from the top of the object is incident on the mirror at X. What happens to this ray? It reflects and passes through the bottom of O. No, it reflects and passes through the top of the O. Yeah. It reflects as though it came from the bottom of I. It reflects as though it came from the top of the eye. You see, this top of the object, if a ray comes from here and here it touches the mirror, it will be reflected from here in this way or in this way. If you prolong it behind, if you look at this reflected ray, you will get the impression that it is coming from the top of the eye. It reflects as though it came from the top of the eye. So D is the option. A little complicated thing. Easy but complicated. The diagram shows light passes from glass. The diagram the diagram shows light passing from glass into air. From glass into air. What is the name of the angle P? That is called angle of incidence. Oh, it's easy. Angle of incidence 25. The option is A. Question number 26. An object is placed in front of a converging lens. An object is placed in front of a converging lens of focal length 4 centimeter. The height of the image is 6 centimeter. The arrangement is shown on the scale diagram. What is the linear magnification produced by the lens? You see, the height of the image is 6. So I can calculate it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the height of the image, I'm counting the squares, small squares. The height of the image is 15 squares. Height of the object, 1, 2, 3, 4, 5, 6, maybe 7. 7. So it's 15, it's 7. So let's divide 7. 15 divided by 7. My answer is 2 point something. 2.4 is my answer on the calculator. So the linear magnification 2.1 means 2. This is question number 20. C is the option. You see, the linear magnification is equals to the height of image divided by height of the object. So I just calculated the squares. What is the height of the image? What is the height of the object? Because he said that this diagram is scale diagram. Height of image divided by height of object gives you the magnification. Linear magnification. Another formula for the linear magnification is distance of the image from the lens divided by distance of the object from the lens. Very easily I can count from here. If you can count what is the distance of the image from the lens and you count what is the distance of the object from the lens divided from the lens divided by the distance of the object from the lens, this will give you the linear magnification. Or you can say the height of the image divided by height of the object also gives us the linear magnification. I hope you understand. C is the option. Question number 26 is done. Question number 27 is on your screen. Which row shows the speed of sound in air, liquid, and solid in order from slowest to the fastest? The sound talking about, he's not, remember, this is not talking about light. He's talking about sound. Sound will be slowest in the air, and it will be faster in liquid, and it will be fastest in the solid. So 21, C is the option. C is the option. Sound is fastest in the solid, medium speed in the liquid, and the slow speed in the air. C is the option. Now we move to next question. Question number 28 is on your screen. A man stands 80 meters in front of a cliff face. He makes a loud bang and listens for the echo. He makes a loud bang once every second. He hears an echo exactly halfway between the bang that caused it and the next bang. What is the speed of the sound? So see, he's making the clap and the bang bang sound after every 1 second, but he heard the echo just half second. After half second, he says he heard it between the one bang and the other bang. Okay, so the time taken for echo to reach him, it is 30 seconds. Not 30 seconds, half second. So the cliff from where the echo is coming is 80 meter. So the sound went to the cliff 80 meter and came back 80 meter again. So the total distance traveled by the sound is 160 meter. So divide 160 meter with 0.5 second. 160 meter divided by 0.5 second. Let's see what's the answer. If I use the calculator, 160 divided by 0.5, the answer is 320. 320 is the speed of the sound. So D is the option. Question number 28. Sorry. Question number 28. D, 320 meter per second is the option G. Question number 29 is right now on your screen. The diagram shows two magnetic field lines of the magnetic field around two bar magnets. Which row shows the magnetic poles at the point? And you see, if you look at here, the magnetic field line is shown. From here, the magnetic line is coming out, and here the magnetic line is going in. So this side from where the magnetic lines are coming out, the P must be north. The P is definitely north. And here you can see the magnetic lines are going in. So this is south. And from here the magnetic line is coming. So this end will be north. So this will be definitely a south. So Q is the south and the P is the north. The B is the option. Question number 29, B is the option. Next question is question number 30. Let's reduce its size a little bit. Okay. On your screen, you can see question number 30. A metal plate X is attached to Earth by a battery. And the plate has a positive charge. A second metal plate Y is initially uncharged and connected to Earth. This plate is positioned parallel to X. What happens to Y as Y is brought closer to X? You see, it's a metallic plate. When you will bring it near the X is positively charged. So here the electrons will be attracted. So when the electrons will be attracted here, so from the Earth, the electrons will travel to Y. Electron flows from Earth to Y. Protons cannot flow. So C and D are not at all. C and D can never be the option because protons do not flow. Electrons flow from Y to the Earth only. Electron flows to Y from the Earth only. The electrons will flow from the Earth to Y. B looks like the answer. Question number 30, the B is the right answer, sir. Question number 31 on your screen. You can see here the question number 31, the diagram shows a metal lightning conductor attached to a building. Why is the lightning conductor made of copper? Because it has to provide the path for the current. If a lightning strikes your home, the lightning conductor will provide a safe path out of the home for the electricity to go into the ground. So it's providing a safe path for the electrons. Both positive and negative charges can flow through the copper. Copper can be electrostatically charged. So the lightning conductor has a low electrical resistance. So the heat is conducted away quickly. So the lightning conductor has a low electrical resistance. Yes, that could be true. C. Copper can electrostatically charge. No. Both positive and negative charges can flow through the copper. Positive charges cannot flow, like negative charges obviously can flow through the copper. So C looks the best option to me. Question number 31, C is the exact and the right option, sir. And question number 32, he says, which symbol does not represent a power source? This is a power source, it's a battery. This is a power source, it's an alternate AC power supply. It's a cell and it's a battery, and this is a AC power supply. This represents a voltmeter. So which one is not a power source? B is representing a voltmeter. It's not a power source. So B, 32, B is the option. Question number 33. On the screen, question 33. Resistors of different resistances are connected to a power supply in either a parallel circuit or a series circuit. Which statement is correct? The current is the same in all the resistors connected in parallel. That's wrong. The current is the same in all resistors connected in series. That's true. When you connect the resistors in series, the current has only one path, so the same current flows through all of them. So B looks good. The voltage across each resistor is different for all the resistors connected in parallel. That's wrong. The voltage across all the resistors same who are connected to parallel to each other. The voltage across each resistor is the same for all resistors connected in the series. No, when you connect them in series, they will have different voltage drops. So the current is the same for all the resistors connected in series. B is the option. Question number 33. B is the option. Question number 34. Okay, on your screen, you can clearly see question number 34. An ammeter is connected to three resistors and a power supply. Which arrangement of resistors gives the greatest ammeter reading? The ammeter reading will be greatest if the resistance of the whole circuit is lowest. The resistance of the whole circuit will be lowest if all of them are connected parallel to each other. So without calculation, I can tell you that this option will have the lowest amount of resistance of the whole circuit. The equivalent resistance will be lowest because they all are connected to in parallel to each other. When the equivalent resistance of the whole circuit is lowest, the amount of current coming from the battery will be the largest, and the ammeter will have the greatest reading. So that's why A is the option. For 34, A is the option. Without calculation, we can answer this. It's just a conceptual question. A hot plate on an electric cooker contains two identical resistors. The switch has three positions. The two resistors are connected in series to the main supply. The two resistors are connected in parallel to the main supply. Just one resistor is connected to the main supply. Which position corresponds to the low, the medium, and the high power ratings? So low power will be when only one resistor is connected, and medium will be when they are connected. I think this is okay. When they are connected in I think in parallel, when they are connected, it will be very high, and when you connect them in series, it will be medium. So I think that the the low power will be when one of them is on, and the medium will be when they are connected in series with each other, and the high power will when they are in parallel. So remember, the heat which is produced depends upon IV, and when you connect in parallel, when you connect those heaters parallel to each other, or you connect those resistors parallel to each other, they both will have the voltage of the battery, and because the total resistance will be less, so the amount of I will be large. So because they have the larger value of the voltage drop, that's why I think when they are connected in parallel, they will have more power. So the option is B. It's a tricky question, not an easy one. Question number 36. 35 was B. Question 36. A main electric circuit is fitted with a circuit breaker rather than a fuse. Where is the circuit breaker connected, and what happens when the current is too low? Circuit breaker is always connected in the live wire, and when the current will be too large, the circuit breaker will trip. The electromagnet in it will open the switch. Yeah. The live wire, we will connect A or B. Out of A or B, we have the option a thin wire melts and breaks. No. A B is the right option, sir. The live wire, an electromagnet opens a switch. That's circuit breaker. Circuit breaker is always connected in the live wire, and when the amount of current increases, it becomes more than a certain amount, and electromagnet acts and it opens the switch, disconnects the live current. Question number 30, the 36 we are done. Question number 37 is on your screen. Transformers are used to transmit electric energy between power stations and transmission cables as shown. Power station. Okay. What is the purpose of transformer in the diagram? The transformer which is used on the power stations before the transmission cables, they are step up transformers. What they do, they increase the voltage. When they increase the voltage, automatically the amount of current reduces. So their main function is to step up, they increase the voltage, decrease the current, and this will help in reducing the power loss in the transmission cables. So what is the purpose of that transformer? To decrease the current and the potential difference from no, to decrease the current and increase the potential difference from the power station, that's true. To increase the current and the potential difference from the power station, no. To increase the current, no. So B is the right option. The function of the transformer is to decrease the current and increase the voltage potential difference from the power station. So 37 said B is the right option. Question number 38. A thermistor warms up as the current in it increases. A thermistor warms up as the current in it increases. Which the graph shows how the voltage across the thermistor changes as the current I through it is increased. Okay. When the thermistor will become hot, its resistance will become smaller. Okay. When the thermistor becomes hot, its resistance becomes less. He says thermistor warms up as the current I increases. It means when you increase the current, its temperature increases. When temperature increases, its resistance drops. Which graph shows how the voltage V across thermistor changes as the current I through it is? You know that thermistor is a non-ohmic conductor, and so the graph should not be an ohmic conductor graph. So when you increase the current, the temperature rises, the resistance drops, the voltage drop or potential difference will be also become smaller. As you increase the current, the thermistor warms up, its temperature rises, and due to rise in temperature, its resistance will become smaller. Then what will happen? There will be less voltage drop across the what's the thermistor. So I think B can be the answer. 38. 38. He says but it cannot happen that at a certain temperature you see there is one problem. If you increase the temperature, it will not happen that at a certain increased value of the current, the voltage drop becomes zero. Okay, so here you see, if you look at the graph A, when you are increasing the current, the voltage drop is also increasing, but the rate of the increase of the voltage is not that same. So it's not a straight line. It's non-ohmic conductor graph. For 38, the right option is A, and the reason is when you increase the current, the voltage drop is not increasing with the same rate, but it is still increasing. So somehow option is A. Question number 39. Radioactive substances are used as tracers in the medical examination. Radioactive substances are used as tracers in medical examinations. A liquid tracer is injected into a patient. A detector 20 centimeters above the patient shows where the radioactive substance is in the body. What is the best radioactive substance to use? You cannot use alpha particles. Alpha particles cannot penetrate the skin. Okay, we will use gamma rays, and we will use that source who is emitting the gamma rays, because the gamma rays can pass through the body or the organs and come out. And we will use that source which whose half-life is just few hours, because when you have injected a radioactive substance into someone, the radioactive substance should be radioactive only for few hours. Okay, so C looks the best option here, gamma ray emitter with a half-life of a few hours. So 39 C is the right option. Question number 40, an isotope of lead 82212 is radioactive after 3 decays. Two beta particles and an alpha, two beta particles and an alpha particle have been emitted. Another radioactive isotope of lead is formed. What is the mass number of the new isotope of the lead? Okay, whenever a beta particle is given out, when a beta particle is given out, there is no, there will be no change in the mass. Okay, so here two beta particles were given out. If there were two beta particles given out, for example, he says two beta particles are given out and one alpha particle have been emitted. Two beta particles given out, there will be no change in the mass. But when the alpha particle will be given out, the mass will reduce by a factor of, it will be reduced by 4. So 21 its mass was 212. So due to beta emissions, there will be no difference. It will have no effect. And when you will alpha particle given, the mass will be decreased by 4. So 212 minus 4, that will be 208. So B looks the option D. Okay, so this paper is done, almost done, and I just want you to go back to question number question number 38 once again, because there was a little bit confusion. A thermistor warms up as the current I in it increases. A thermistor warms up as the current in it increases. Oh, its temperature is increasing. So which a thermistor warms up as the current in it increases? Which diagram shows how the voltage V across the thermistor changes as the current I? Because the thermistor is warming up, it means the heat dissipation. I'm doing this question again. I have to make it more clear. See, your current is passing through the thermistor. When you increase the current, the thermistor started heating up. It means that the current, the electric energy is converting into heat energy. The more current you are passing through it, the more heat energy is produced. So it's not that normal thermistor which we studied in our course. So what is happening here? When you are increasing the amount of current in the thermistor is heating up. The electric energy is converting into the heat energy. So it means that the power is given by I is equals P is equals to IV, or the energy is given by IVT. So if the I has increased and the power has also increased, it means the power dissipated, it has increased. So it means the value of the V has also increased. He's not talking about a thermistor, normal thermistor, which we study in our course. So A is the best option. And when you increase the current, the voltage drop will also increase. But thermistor is not a ohmic conductor, it's a non-ohmic conductor. So the competition is between A and D. Then the A will be the option because it's a non-ohmic conductor, so the graph will be a curve, it's not a straight line. Thank you very much. I hope I have made this paper, I did my best to make this paper clear. Thank you very much.